Many of us own multiple computers and devices that are underutilized most of the time. Some of us have also access to many computers at our offices. Wouldn't it be nice to use them as a personal cloud computing platform when we need extra computing power? Pando.js allows you to do exactly that. In this video, I'll show you how to use Pando as a command line tool. You will learn how to write a simple processing function in JavaScript and how to integrate Pando in a Unix pipeline. Pando expects a stream of inputs and produces a stream of corresponding outputs. In this example, we use sequential numbers from 1 to 3 as inputs. They have different colors to make it easier for us to track them as they flow through the system. From the point of view of Pando, though, they are really just a regular stream of integers. The outputs are computed by applying a function to each input. In this example, we use a function that squares its input. Pando does not process values by itself. Instead, it starts an HTTP server in the background and provides a URL at which other devices may connect to process the value. For example, you may connect your tablet by opening the URL in a web browser. The browser then automatically asks Pando for an input value to process and applies the function to the input. To increase the processing speed, you may connect more of your devices, such as a desktop and a laptop. Once a result has been computed, it is returned to Pando. Since some devices may be faster than others, Pando holds the results until all previous inputs have been processed. If all previous inputs have been processed, then Pando outputs the result as it receives them. First, let's create some inputs. Here, we use the count sequential number generator that is part of the Pando repository. It counts from 0 to infinity. I show the numbers here by piping them through PV to slow the rate to 3 bytes per second so you can see them as they are created. Next, we write a processing function in JavaScript. A Pando function is really just a node module with a special property for declaring an asynchronous function that is compatible with Pando. The function takes a single argument x and a callback to return the result. For this example, we will slow down the computation to human speed. In order to do so, we introduce a timeout of at least 1 second with a little randomness added to it to force Pando to reorder the result as they come in. Following the usual node convention, the result is returned by first passing the null arguments and then the result, in this case, the square of the x value. We now save that function and go back to the command line. Let's now use Pando to process this stream of numbers. Pando takes the function and will package it automatically for the browser using browserify. In addition, we pass the stdin command line argument to tell Pando to read inputs from the standard input. Once Pando starts, it outputs a URL at which other devices can connect. If we take that URL and paste that into a browser, then it will connect to the Pando executable. To maximize resource utilization, you should open one page per core on your machine. In a modern browser, each page runs in a separate process. By opening one page per core, you are using all the cores available on your machine. You should probably not open more than one page per core though, otherwise multiple pages will start competing for the same core and the overall processing speed will be slower. You can now see that processing has gone faster as we added more cores. Using Pando, you can now start to use all your devices for processing jobs and combining that with all the Unix tools you already know.